I would like to convey my thanks to Rajiv Gandhi National Institute of Youth Development and Cochin University of Science and Technology uh, in, for giving an opportunity to take a session on the 5-day show. Okay, in this session, I would like to discuss about the necessary pre-processing steps before doing a machine learning task. Okay, I think you got familiar with the NumPy and Pandas library in the last very hands-on session. So first thing is we want to import the necessary libraries. Okay, so to start with Pandas and NumPy, we need to import these packages. For that, you can use the set of code that is importing Pandas as PD and import NumPy as NP. And next step is we want to import the dataset. To import the dataset, we use the read_csv method of Pandas and store it in the data frame named as df. Okay, here we have used the pd.read_csv function to read the CSV file. That is our dataset. And it will store in a data frame. A data frame is a two-dimensional mutable and mutable data structure in Python. It is a combination of rows and columns like an Excel sheet. Okay. So here I have used a URL of the dataset. So it will load the dataset from this URL. Okay. Then this to return the dataset. Okay. This is our dataset and in data frame. Okay. It has 1,599 rows and columns. That means total length of the data is 1,599 rows and we have 12 features in our dataset. So it's a wide quality dataset. So the fields are related to that wine quality. So it has fixed acidity, volatile acidity, citric acid, and residue sugar like that. And also you can see the quality of the wine. Okay. Then the shape function also returns the number of rows and columns in the dataset. That is the shape of the dataset, code data frame. And next, the head method. This function returns the first n rows for the object based on position. Okay. So executing this, you can see the first 10 rows of the data frame. Okay, 0 to 100. And the next one is tail. This function returns the last n rows for the object based on position. Okay, you can see that the last 10 rows were okay. So the last 10 rows were showing in while calling the tail method. So next, we are going to discuss about the Pandas describe function, which is used to view some basic statistical details like percentage, mean, standard deviation, etc. of a data frame or a series of numeric values. So this will return the count, mean, standard deviation, minimum value, the quartiles, and the maximum value. So from this we uh, can understand that the each this the total count of the values in each variables or each features, that is 1599. That is the shape of the raw number of our data set. So it is which has no missing values uh, in this field. Okay, all the features have the same number of same number. So this data set is uh, so good data set because it has no any missing values. Okay, and next is the mean. So it means that which take it returns the 8.31 what is the mean of that corresponding column value, and the standard deviation is the standard deviation of the uh, column value and their column values, and the minimum is the minimum value in this fixed acidity feature, and 25 percentage is the 25 percentage of the entire data set. The fixed acidity is 7.1, and the 50 percentage of the entire data set uh, uh, of the fixed acidity is 7.9, and the 75 percentage of the uh, data set for fixed acidity is 9.2. Okay, and also it returns the maximum value for each features. For fixed acidity, it is 15.90, and like that, all others have maximum values, and the display function will give a basic statistical details of the data frame. Okay, next is the correlation function. Correlation function computes pairwise correlation of columns. Correlation shows how the two variables are related to each other. Positive values shows as one variable increase, other variable increases as well. And negative value shows one variable increases, other variables decreases. Bigger the values, more strongly two variables are correlated and vice versa. Okay, here we can see that the correlation of fixed acidity and volatile acidity is minus 0.25. Okay, so it is negative value, is a negative value, which shows and as one variable increases, other variable decreases. Okay, like that, all the features are correlated vice versa. Okay. Okay, next is the group by method. So here we are calling the group by function along in the use on the group by function on the data frame object, and we have given the quality field as parameter. So we can see that the quality field has the values 3, 4, and 8, and will group by the total number of values have total number of rows having entries have the quality 3, which is 10, and the quality 4 has 53 uh, 53 uh, 53 count, and the 5 has 681, and the quality 6 have 638, like that. 7 and 8 have 199 and 18. Okay, so the group by will grouping of the same values and same values of the of a particular variable. So next we are going to discuss about uh, about the missing values. Okay, so areas like machine learning and data mining face severe issues in the accuracy of their model predictions because of poor quality of data, which is caused by missing values. Okay, in these areas, missing values treatment is a major point of focus to make their models more accurate and variable. Okay, for that, all of you please uh, import the dataset which I have shared with you. Okay, I have shared the placement dataset. You can upload in your drive or you can upload here. Also, you can upload your dataset. If you are uploaded in your drive, you have to specify the path here, path to the dataset here. Otherwise, you can give the placement dataset.csv here. No need to give the path. Is that the methods that we have discussed are clear for you? So should I tell once more? If it is okay, please respond. Okay. Have you loaded the dataset? The placement dataset. Hello. Are you able to load the dataset? Now you can load the dataset in your drive, or you can upload directly here using this button, upload to session storage. Once you have downloaded the dataset, you can upload the dataset directly to the session storage. Okay. You can load the dataset directly from your local storage to the session storage, or you can upload the dataset in your drive and provide the path as parameter. Okay. Some of you have got the idea. Okay. And for the action, this is the data frame. The shape of the dataset. All of you, please find the shape of the dataset. I think somebody has some problem in the sort of load the dataset. How can we change slash to that action path? Suppose you have loaded the dataset in your drive, you can access that from here. Okay, this is the path to the dataset. So you can copy the path from here. I have uploaded the dataset in my drive in this location. Copy the path and you can simply paste it in the.
Can you share the screen? The screen was stopped.
Okay, okay.
Okay, sir. Thank you.
So the messages are not when I share my screen. Okay, this is okay. This is my drive, and I have uploaded the dataset in this folder hands-on, and this is my This is my data set. Okay. So from here, we can copy the path of the data set. Simply we can paste it here. Even as the CSV method. Okay. Here. Small your drive. The option here. The drive. The location where you have uploaded your data set. And click on the three dots. Just copy the path. Is it clear? Simply load the data set from your local storage. Upload file to the session storage. Instant data set. Only starts to load. Okay. This is another method. The problem is if the session expires, the data will be disappear from here. Okay, will be removed from the session storage. That's why I have first put the data set in my successful from my drive. These are the two methods to upload your data. Any files. Is it clear? Hello. Hello. Am I audible?
Yes, sir, you're audible.
Okay, thank you. Those who have loaded the data set, please type 1 in the chat box. Please type 1 in the chat box. So please respond. Okay. I think you are able to load the data set. Okay. Then the head function, which return the top rows of the data set. Okay. Please, all of you, please identify the shape of the data frame using the shape function. And you can type the shape of the data frame in the chat box. Okay. 215 and 50. Right. Yeah. So it has 215 rows and 15 columns. So we have already told about the missing values, and for identifying the missing values, to make detecting missing values, pandas provides the is null method and not null function, which are also used in the series and data frame objects. Okay, so this is our data frame object dataset 1, and the is null is used to detect the missing values in the dataset, and the sum will count the missing values. Okay. Okay, you can see that these are our fields. These are our 15 fields, and it shows that 0, the fields or the fields up to status have no any missing values, but the feature salary has 67 missing values. Okay, so we want to remove the missing values first. For that, we have 3 methods to input values to the missing values to the values values missing in a particular uh, feature or column. Okay, so for replacing the missing values, here in this first step, I have used the median. To replacing the missing value, we can give the code like this. That is data set. First, we want to access the particular field which has missing values. That is salary, and the fill now method is used to fill not applicable values with the non-null data. So we are filling the values uh, values to the position which have missing values, and for that we want to take the median. So we are taking the median of the salary feature salary, and we are filling the median value in the missing positions. Okay, so dataset 1 is the that dataset object, and the field is salary, and we are taking the fill we are uh, we are using the fill now method for filling the missing values with the median of the particular field salary. Okay, in place is true. Okay, you can see uh, this false means which has no any null values. And then you can see the entire data set values is showing false, 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 which means it has no any missing values, but it is not showing the entire data set. Uh, uh, so we did not amplify by just simply executing this code. So we have uh, added this sum method also here. Then we got the number of missing values each pages. So salary has 67. Salary has 67 missing values. Others, all other fields has no one missing values. So in that case, so wherever the value is true, okay, wherever you have the value is true, we will fill the median value of that particular field in the true location. Okay, location where the value, in which place we have the value true in our data frame. At locations, we are imputing the median value of the salary fields. Variable salary, we are taking the median of the variable salary and imputing the value, median value to the places where the data frame has true value. Okay, so this is the one method for imputing uh, values to the missing positions. And next we can check uh, our missing values. Set of code. Then checking for missing values. Now it's 0. So we have the median value in the 67 positions, missing positions. Okay. So we can use the mean and mode some tendency for filling missing values. Okay, these are the syntax for filling missing values using mean and mode. You can try it. All of you please try to fill the missing values with the mean values. And also check there is any missing values after fill up function. The median method is used when if the data does not exhibit some skewness, that is, there are a small number of very large values, then the median may be better choice. And when the mean is used when we might choose the mean. For example, if the variable is generally uh, um, normally distributed. Okay, and the mode is used to when the data are in categorical, and we might choose to use the mode as the default to fill in for the otherwise missing values. The method can also be used for numeric variables. Okay, mostly the mode is used for categorical variables. Okay, we have discussed about the missing values. Um, to detect the missing values, you can call the ESR method along with the dataset object. Okay. Some function will provide the total number of missing values to a particular feature. And we have three ways to impute the values in the missing positions, that are mean, median, and mode. The median value of the feature using FILNA method. First, we want to access the first we want to give the particular feature, that is data set of salary. Salary has in our example, salary has the missing values. So we want to impute the values to this salary column. Okay, using the FILNA method. And the FILNA method, we are providing the median function, and we are taking the median of the same salary column. Okay, and in the locations where we want to impute the values are true. Okay, missing values positions are represented using the true value. Okay. After running the FILNA method, you can check for null values, then it becomes 0. Like that, you can also use mean and mode. Okay. So handling missing values, first we have discussed about how to values to the missing options. Next option to handle the missing values are dropping method. We can drop the entire row. Okay. For that, you can use the same data set. Now we have 215 rows of values, and we are checking again. We are checking for the missing values, and it is 67, and we can use the drop now method for dropping the rows of data having missing values. We can use the drop now method. So here we have created the variable salary data set, and salary data set dot drop now. Salary data set is our data set object, and salary data set dot drop now will drop the drop the fields which have missing values. Okay, so drop now, in the drop now you can see that how is equal to any. So if you want to simply exclude the missing values, then use the drop now function along with the axis argument. By default, axis equal to 0 along row, which means that if any value within a row is not applicable, then the whole row is excluded. If any values in the row is missing, then it will remove that row. If we provide all here, Okay, I will show that. Okay. Now the missing values are 0. Then you have, then when you check the shape, you can identify that the shape is reduced to 148. Initially, we have 250 rows of data, but applying the drop-down function, it reduced to 148. That is, it remove the 67 rows from the data set. Okay, is it clear? Is it clear to handle how to handle the missing values? Okay, thank you. Next, we are going to discuss about data transformation. For that, we are again using the fine quality data set. So we have imported the necessary libraries and loaded the data set. The correlation that we have already discussed, we can find the correlation between the features. Here I have used the fixed acidity and volatile acidity. It is negatively correlated. That means if the fixed acidity increases, the volatile acidity decreases. Okay. Okay. For the transformation, we have different scalars are there. That is min-max scalar, standard scalar, robust scalar, and normalizer and binarizer. Okay. So for the transformation, uh, uh, first we want to convert the data frame values to an array. So in this example, I am using the arrays. You can also use the data frame directly for scaling the data. This is another method for scaling. You can also use this method. That is, first we are converting the data frame values into an array. That is, df dot values will stored in a variable, and it should be an array. Then we want to separate the input data and input and output components. So here we are taking the array entire rows, that is shown here, the entire rows and columns up to 8. Okay, 0 to 8. That means 0 to n minus 1, 0 to 7. Okay, then in the y, we are taking the entire rows and the 8th column only. Okay, can see that. So we have taken the data frame values to the array, and while printing the array, you can see the values is stored in an end array, and dimensional array, and the x has values like this, and by the entire row values to a particular column. And we are using the min-max scalar here. So the min-max scalar is one of the simplest scalar. It converts the value into the range of 0 to 1. So the 0, 1 is defined range of the scalar, but we can change this as per our preference. Okay, we will begin with importing the min-max scalar from sklearn. Okay, you can see that we have imported our min-max scalar here from sklearn. from scalar and dot preprocessing, import min-max scalar. Okay, then we are creating the object of the scalar, min-max scalar to min-max scalar of feature range. So in this case, we are using the range 0 to 1. So all the values will come to this range 0 to 1. Okay. Then we are rescaling the x. Okay. We want to rescale the so we are fitting the transform with the x array. Okay, the array x. Okay, and calling the scalar in a scalar object here and fitting the transformation transform of the array to the scalar. So the rescaled array x will be like this. All the values are in the range of 0 and 1. Okay, and the next data transformation method is standard scalar. So we want to import the standard scalar from the SKLN preprocessing package. From SKLN preprocessing, import standard scalar. In the min-max scalar, we have imported the min-max scalar library. For the standard scalar, we want to import the standard scalar. And same as the min-max scalar, we want to create the object of the standard scalar and fit the array to the scalar, and we are rescaling the x array. Okay, here you can by putting the cursor on the rescaled x, you can see that the shape of the end array. End array means the n-dimensional array. It is 1599 and 8. This means it takes the entire row and 8 columns. Okay, so x has the entire row and 8 columns. And when we are applying the standard scalar, it is scaled to this. Okay, and the standard scalar is also one of the popular scalar used. It scales the value such that the mean is close to 0 and standard deviation is close to 1. It assumes that the data is normally distributed. So it can be seen that the standard scalar has converted the standard for each variable very close to 1. So next is the overscaling. All the above explained scalars uses mean, maximum value or minimum value, but these values are pretty sensitive to the outliers, the unwanted or unwanted data or the noises. So the robust scalar uses interquartile range, which is not sensitive to the outliers. Okay, so in the robust scaling, we have using the interquartile range, and which is not sensitive to the outliers. For that, we want to import the robust scalar library from the same scalar and preprocessing package, and creating the object for robust scalar and fitting the array to the robust scale object. This is the transformer form of the array. Next is the normalizing the data. For that, We want to import the normalizer from scalar reprocessing. Normalization is the process of scaling individual samples to a unit norm. One of the key difference between scaling or standardizing and the normalization is the normalization is a row-wise operation, while scaling is a column-wise operation. Okay, so after normalizing, the data is transferred to next is the feature binarization. Feature binarization is a process of thresholding numerical features to get Boolean values. Okay, or in other words, we can say assign a Boolean value to each sample based on a threshold. Here you can see for the scalar, we are importing the binarizer from the scalar preprocessing package and creating the object binarizer of the binarizer by giving the threshold value as parameter. Okay, so the threshold is 0. All the values, no, all the values which are greater than 1 is 1, and sorry, all the values which are greater than 0 is 1, and all the values which are less than 0 is assigned to 0. Okay, you can see that here it is normalized to this form. Here we have only two values, that is either 1 or 0. By setting the threshold, we can get the input. Okay, if we as our preference, we can give the threshold value. Okay, next, these are the basic transformations. Next is the level encoding. Have you played the topics? I think by mathematically, these are the things that is discussed by uh, uh, by our resource person, Dr. Adita Shanaisa. So I discussed about different statistical and mathematical tools. Or theoretically, we have discussed about all these things. Computationally, we can do these things by calling the packages. Python has all the packages for statistical analysis of the data. Okay, shall we move to the next method? Hello. Hello. Okay. If you have any doubts, please unmute and ask. I will try to play. Okay. So next is the label encoding, which encode target labels with values between 0 and n minus 1 classes. Okay, this transformer should be used to encode target values, that is the y and not the input x. Okay, so for the label encoding, here we have we want to import the label encoder and uh, encoder and wants to create the object of the label encoder. So the label encoder is the label object of the label encoder method. And we have the input classes as this is a list which has the names Havels, Phillips, Cisco, Everdy, and Lloyd. Uh, and it's a list. So this is our input data, and we want to uh, change the of we want to encode these labels. Okay, we want to change the encode the uh, label Havels to some integers. Okay, that is Havels is here, Phillips, Cisco, everyday, and Lloyd. So we want to change the values to some specific integer values, that is 0, 1, 2, 3, and 4, like that. For that, uh, we are fitting the label encoder on input classes. Okay, the label encoder is the our object, label encoder object. So by executing this, we can see that the everybody is uh, assigned to 0, Harris is assigned to 1, Lloyd is assigned to 2, Philip is 3, and Cisco is 4. It is arranged based on the alphabetic order. That is, E is the first one, so 0, and Harris is 1, and Lloyd is 2, Phillips is 3, and Cisco is 4. Okay, so this is how we can transform the categorical data into numerical values. Okay, also you can see that suppose the labels are Lloyd's choosing these 3 labels. We want to transform it to we want to find the label of is 243. The array, it is 243 because Lloyd has the value 2 and Cisco has the value 4 and Phillips has the value 3. So we can apply the inverse transform. Is if we have the array value to the encode, we can convert it to categorical labeled values. That is, we have 2. 2 is actually Lloyd and 4 is Cisco. The label encoder to convert the label values to integer values, and also we can apply the inverse operation. And next is the one-hot encoding. A one-hot encoding is a representation of categorical variables as binary vectors. This first requires that the categorical value be mapped to integer values. Okay, then each integer value is represented as a binary vector, that is all 0 values expect the index of the integer, which is marked with a 1. Okay, we know that the categorical variables contain the label values rather than the numerical values. So categorical variables cannot operate on label data directly. That's why we are uh, converting or encoding it to an integer. Okay, uh, so the models like algorithms which cannot operate on label data. They require all input variables and output variables to be numeric. We can first convert the data into numerical variable, numerical values. For that, we are using the label encoding and markup encoding. So first, we want to import the label encoder and format encoder. And here we have the value for list of values, that is apple, mango, apple, berry, mango, apple, berry, and apple. These are the elements, and the list is cat data, and this is the categorical data, and we are creating the label encoder object, and we are fitting the uh, fitting the label encoder the categorical data to the label encoder object, and we got the and we will get the encoded integer data corresponding to the label data, corresponding to the categorical data. While running this, we will get the clear idea. Okay, you can see that we have encoded the categorical data into integer data, and it the apple has the value 0, and the berry has the value and the mango has the value 2, and apple it is 0, and berry is 1 and 2, mango. Okay, apple 0 is apple, and 1 is berry, and 0. Okay. So we have label encoded the data, and we are applying the one-hot data, one-hot encoding. For that, we need to create the and we will fitting the integer data for label encoded data to the one-hot encoded object, and the categorical data encoded into the integer values. Okay, so we can see that here it is 42100. So because in the first row we have only the apple. Okay, no other uh, no other elements are there. So okay, so it will assign one value one to the apple, and two and the other two have 0. Okay, now but in this you can see that the value of apple and berry is 0, and the mango has 1. Okay, so therefore the row is same. If we see apple and mango are not there, okay, it is 1. Okay, we have to 1. After encoding, you can see that the berry has the value 1 and all others has 0. So by converting that to compute our machine in computation computation will give some advantages, that is storage and computational speed. Okay, I will tell once again. Basically, the label encoder is used to convert the categorical values to numerical values. In some machine learning tasks, the algorithm should work only once in the numerical data. So we want to convert the categorical data or labeled data to a numerical data. For that, we are using the label encoder. First, we want to create the label encoder object. Then we will fitting the uh, fitting the data to the label encoder. Okay. So in this example, you can see that uh, the the labels are encoded to corresponding or labels are encoded to some integer values. Okay, that is like 0, 1, 2, 3, and 4. And uh, and next is the one-hot encoding. One-hot encoding is basically used to reduce the computational uh, uh, or reduce the computational effort, or what we can say, to reduce the storage and to perform the task more fastly. Okay, for improving the speed and reducing the storage, we are using the one-hot encoding. For that, first we want to label and encode our data. So the categorical data is our is stored in a list. In this example, we have the categorical data as apple, mango, and like that. And we want first we imported it into some numerical values, and we applied the one-hot encoder on the numerical values. Okay, so we got the one-hot encoder form here. You can see that it will assign the values. So it will raise the value 1 when the element is present, that is apple. First we have the apple, that is 0. At that time, uh, in this case, it has the value 1, and or the other two variables has the value 0. In the case of in the second we have the mango. For that we have value 1 as the question mango, as the 2 apple and berry has value 0, and it is again and 0. So the value is 1 for apple, and mango and berry has 0. If the label and code is 1, that is berry, then all other two values are same. Like that, it will assign to the all values in the data set. Okay. So this is another example of the correlation. Here we have created the data frame using the dictionary method. We have three features: points, assists, and rebounds. And suppose we want to calculate the uh, correlation between points and assists, we can call the correlation function data frame points dot correlation assist. Okay, so the data the variable points is correlated with the assistant is negatively. That is, if points increases, uh, the assist will decrease. That is it. That's why we call it as negatively correlated variables. Okay, this is about the basic things. And next we are going to the data reduction technique. Data reduction. We can open the next notebook data reduction that I have already shared in the chat box. You can just open that notebook. Those who are ready with the second notebook, please type 1. Please type 2 in the chat box. Okay, hope you have ready the notebook. So in this we are going to discuss about the data reduction. When we are thinking about the data reduction, we have a high dimensional data set that has a great number of columns. Such a data set presents many mathematical or computational challenges. Okay, although high power computation can somehow handle high dimensional data, in many applications, it is still necessary to reduce the dimensionality of the original data. Both in this, we are going to discuss about the principal component analysis. Uh, so, both the PCA and LDA are linear transformation techniques. PCA means principal component analysis, and LDA is the linear discriminant analysis. However, PCA is an unsupervised and LDA is supervised dimensional reduction technique. PCA has no concern with the class labels. In simple words, PCA summarizes the features set without relying on the output. And PCA tries to find the directions of the maximum variance in the dataset. In a large feature set, there are many features that are nearly duplicate of the other features or having high correlation with the other features. Okay, and such features are basically redundant and can be ignored. So the role of PCA is to find such highly correlated or duplicate features and to come up with the new features set where there is minimum correlation between the features, or in other words, the feature set with the maximum variance between the features. Since the variance between the features does not depend upon the output. So that's why the PCA does not take the output labels into account. And more about PCA and LDA. PCA and LDA tries to reduce the dimensions of the feature set while retaining the information that discriminate output classes. And the LDA tries to find a decision boundary around each cluster of a class. It then projects the data points to new dimensions in a way that the clusters are as separate from each other as possible, and individual elements which a cluster are as close to the center. The new dimensions are tagged on the basis of their ability to maximize the distance between the cluster and minimize the distance between the data points within the cluster. Okay. These new dimensions form the linear discriminant of the feature set. This is the introduction to these two data reduction techniques. And in this, we are looking to the PCA data reduction technique. Okay. For that, the necessary libraries are numbers and Panda. And we have imported the necessary libraries. Next, we want to import the data set, overload the data set. Here you can see that here I have given the URL of the data set, and you can create the data frame using the URL. And we have chosen the given the features also: sepal length, sepal width, petal length, petal width, and target. So these are the fields of the data set. Okay. While you running this, we will get the data frame. Okay. So in this data frame, you can see that the values corresponding to each labels, each features. Okay. And the target column is iris sectosa. Okay. Sorry, and now my screen is visible. isn't it? Yes, okay. So all of you please import the libraries and then load the data set. Hello. I think you have loaded the data set and displayed the data frame. Okay. Are you doing along with me? We have imported the necessary libraries and loaded the data set. In this example, we are using the iris data set, which has the fields sepal length, sepal width, petal length, petal width, and the target. These are the columns or features of the data set. Okay, so we have loaded the data set. Next, we want to standardize the data. Okay, all the variables should be on the same scale before applying the PCA. So standard scalar is used for scaling or transforming the data. So we can see that we have imported the library for standard scalar, which is SKLM preprocessing. From the SKLM preprocessing library, we have imported the standard scalar library. And for the PCA, we have only using the input variables and that which is we will not consider the target. Or okay, for that we want to separate the data frame. That is X has the values up to the petal width. Okay, so for that we are using this method data frame dot log. Log means will locate the data frame values. So we are choosing the entire rows and the variables. In the variables we have the four features for standardizing. Okay, and okay, so now X has the values uh, of the variables sepal length or variables for the features sepal length, sepal width, petal length, and petal width. Okay, and Y has the entire row values and the target column, that is iris setosa. Can see that here. Here we are taking that is data frame dot log and their row. This means entire row. We are taking the entire row. Okay. To end, and we are specifying the column, that is variables. Okay, column values are sepal length, sepal width, petal length, and petal width. Okay, and the values of these columns. Okay, the dot value will take the values of these columns. That is the value we want to standard or scale using the standard scaling. And we are allocating the target column to Y. Okay. So we are applying the standard scalar, fitting the X variable to the standard scalar to standardize the values in the variable or X. Okay, this is the standardized form of X. Okay, using the standard scalar, and once we have standardized our data, then we can apply PCA. So, okay, there are 4 features in the original data. So PCA will provide the same number of principal components. Okay, while applying the PCA, you can see that okay, first of all, we need to execute this code. Then we are applying the PCA. For applying PCA, we want to import the PCA library from skline.decomposition, and we are creating the object of PCA and fitting the scaled X values to the PCA, and we are creating the data frame of the PCA, and this looks like this. And use the PCA.explained variance ratio to return a vector of the variance. Okay, and it shows that the first principal component accounts for 72.22. Okay, which is 72.22. We can take it as 72.22% variance. That is the first. It shows that first principal component accounts for 72.22% variance, and the second, third, and the fourth accounts for 23.9, 3.68, and 0.51%. Okay, then we can say 72.22, and the second component 23.9. Together we get 96.21% of the information is captured by the first and second principal components. So we often want to keep only the significant features and drop the insignificant. A rule of thumb is to keep the top principal components that capture significant variance and keep out the small ones. Okay, so here we are only considering the first and second principal components. So that's up to the data reduction. Similarly, you can perform the LDA, linear discriminant analysis. You can try out that, which has the package linear discriminant. It is also necessary to standardize in the data, and you want to you can import the linear discriminant analysis library from the skline.discriminant analysis package. Okay, that's up to the processing task that we can put that you can do before a machine learning task. Okay, I think it's still up to you, because you have already attended the morning session on this, the theoretical session on this PCA, LDA, and the statistical methods on the data science task. Okay, so if you have any doubts in this, I'll try my best to clear it out. If you have any issues like that, you can ask. Otherwise, we can wind up this session. I think so. Thank you, ma'am.
Yeah. Yeah,
Thank you.
okay. Thank
Thank
you.
you. Thank you.